Hello everyone, welcome to the 11th lecture of the series on AI using Python. In this lecture, we will be giving a brief introduction to classification. So far, in this lecture series, we were discussing various regression algorithms in which the objective is to construct a model which can predict a continuous variable. Now, when it comes to classification problem, the output variables or the dependent variables are discrete, which can take only finite number of possible values. And our objective is to find a model which can map the input data to a discrete output, or in other words, classify the input into different categories. We have seen that both regression and classification comes under the class of supervised learning. This means that the available dataset contains inputs and outputs. The classification algorithms can be divided into linear classification and nonlinear classification. Whereas the linear classification uses the output value of a linear function for classifying the data, and it is suitable if the data are linearly separable. Nonlinear classification uses the output value of a nonlinear function for classifying the data, and it is used if the input data is not linearly separable. Next, we illustrate linear classification and the idea of linearly separable data. To illustrate linear classification, we are considering an example in which the data is linearly separable. Here, we are considering the input data with two variables, which we denote by xtr1 and xtr2. The variables in xtr1 and xtr2 can be corresponding to two classes, and in xtr1 we select the first 50 samples corresponding to class 1 and we denote it as xtr1 underscore 1. Similarly, the next 50 samples are corresponding to class 2, which we denoted by xtr1 underscore 2. Here xtr1 underscore 1 contains 50 data points which are chosen from the interval -6 to 2. Similarly, xtr1 underscore 2 contains 50 data points which are chosen from the interval -2 to 6. To generate the second input or xtr2, we are using a linear relationship of the form ax plus b, where a and b are chosen like this. Now xtr2 underscore 1 is defined as a into xtr1 underscore 1 plus 5b plus 3r, where r is defined using the random state function. And similarly, xtr2 underscore 2 is defined as a into xtr1 underscore 2 minus 5b minus 3r. So here these plus and minus signs are used for separating the data points so that it becomes linearly separable. Note that this is just a made up example to illustrate linear separable case. That's why we selected the first 50 samples from class 1 and the next 50 from class 2. In practice, these samples will be mixed and there may not be any direct pattern like this. For example, the first two samples can be from class 1 and the third samples from class 2 and so on. Now we can plot xtr1 versus xtr2 for the samples from class 1, for which we use the red color, and for class 2 samples we use green color. And we obtain the plot as shown in this figure, where the red dots corresponding to the points from class 1 and the green dots corresponding to the points corresponding to class 2. And here we can see that we can draw a line in between these two classes. This means the data is linearly separable. Now in linear classification, our objective is to find a line that separates these two classes in an optimal way. In other words, that has maximum separation between these two classes. Next, we move on to the illustration of nonlinear classification. And here also we are using a similar example with the 2D data, whereas here the data points are selected using a nonlinear relationship. And here also this underscore 1 denotes the data points corresponding to class 1 and underscore 2 denotes the data points corresponding to class 2. Now we define xtr1 underscore 1 as 100 data points in the interval -8 to 6, and xtr1 underscore 2 is chosen as 100 data points in the interval from -6 to 8. Then xtr2 underscore is defined as a3 into xtr1 underscore 1 cube plus a2 into xtr1 underscore 1 square plus a1 into xtr1 underscore 1 plus 5b plus 3r, where a3, a2, a1 and b are chosen as here. And similarly, we define xtr2 underscore 2, where we use -3b instead of +5b. and -4R instead of +3R, which are used for separating these two classes. Now we can plot the data for these two classes for both XTR1 and XTR2, which gives the plot as shown in this figure. Here we can see that the data points corresponding to these two classes are more closer, and we cannot separate them by using a line. This means the data is not linearly separable, and we need to use a curve for separating these two data points. In other words, here we need to use nonlinear classification. In the next few lectures, we will be focusing on various linear and nonlinear classification methods. And in the next lecture, we discuss support vector machine, which is a popular linear classification method. With that, we comes to the end of this lecture, and thank you.